What's up, guys? It's Minx. In the last video, we ended off with some basic movement. We got jumping. Movement's not like great or anything, but it's functional now to the point where we got collision and movement. So that's a good start. In this video, we're going to add the camera moving around. So as you can see, if you haven't noticed, I've added a cube here, and I've actually expanded the ground so it goes a little further. I can go off screen and come back, and it won't break me. So we're going to make it so we can kind of follow through, and this cube and this being a little longer will give us an idea of it working. So the camera's going to follow us around, and in the next video we're going to be working on level generation. So I will probably have like a grid or something that we use that we'll have to figure out how to make. So let's go ahead and get started with this one. Let's close out of this. So to do just a quickly go over what I did off camera. All I did was expand the for loop here and make it 20 instead of 14. And then I just added another one, just spawns here, and it's at 800. So it's at the, it's at the 8th spot. You could put it wherever you want. And otherwise it's the same. Everything else is the same. So we're gonna really quickly, there's a couple changes here. I didn't revert them from testing, but we need to add, we need to make position and speed public. We don't need to make scale public. At least I'm not going to, or I'm not going to use it. I'm going to make it public because why not? But the purpose of scale being public, I'll try and make clear later. So when we check the camera movement, we need to see where the player is. And if you want it to be like exact same size on each side when we do like tolerance and stuff like that, you can check the right side of the player instead of the left side. Let me pull up paint. So if this isn't already clear, when you have when you have this cube, this is the player. Your point is here. So this is X, Y, and then you have your width and your height. So when you check at this point. So your X, check here, and then you check Y. So when you if you want to check like if the player is this far from the screen at this point, you have to check X plus W rather than just X. So keep that in mind. If you want to be that specific, you can. I'm not going to, though I'm going to leave it public. So let's go ahead and not save that. And let's hop over to game window now that we've made these public. Pretty much everything in this one's going to be happening in game window. The reason being is camera is going to be used outside of when the player's active. So we're likely going to have a player class that it's going to derive from player, and the player class that derives from player is when we do like level creation is going to it's going to control the camera. It's going to tell us where we go and stuff like that. So that should help, because what we can do is say, hey, the tolerance when we use this is 0, so it feels like we're just controlling the camera. We can also say, hey, there's no collision with this, so we can just move the camera around wherever we want. So that should help a little bit. This will give us a little bit of fluidity here. So, okay, let's hop down into a new method. Let's actually, no, let's make our variables first. I was thinking we'll do that, but no, we need our variables. So looks like player isn't actually used for anything. It's used, it's assigned but never used. We're going to assign it. I think we made that in the last video. If not, make it. So we're going to do private vector2. We may change it over to public, but not. We'll see. And it's going to be called camera. And it's actually, we're going to set it equal to vector2.0. So when the camera first spawns in, I'm actually going to bring paint back out because we're going to need it multiple times throughout this video. When you have so this is your screen, and your default screen is like this. The vectors, the camera's like starting point or whatever, translation is 0, 0. So it starts there, and that shows you the whole screen. So that's good for this. We want that. We want a private vector2. And we want to call this one, I'm going to call this, you could call it adjusted player position or player screen position. Call it whatever you want. Make it make sense. I'm going to put a comment here to say what it is, so to clarify. This is the player position on screen currently utilized for for camera following. And then we're going to make a private bool. Actually, I'll make a private bool. Private bool enable auto cam equals false by default. So the way, and this will probably be the last time we use paint. maybe second last. I don't know. We have our normal screen. It's up here. Okay. And we have here is 0, 0. This is 19. We'll say 1920 by 0. I'll assume this is a 1080p. And then 1920 by, what is it, 1080? Okay. So you have this, and then you have a random point. We'll put it in the middle, but we're not going to like call it anything. I will say X, Y. So if we move in any direction, the camera moves. This XY of the player doesn't change. The player is still at XY. However, let's say we moved it exactly negative 1920 0 over. And we had the player in the middle still. How do we get this? So the way that I like to think of this, and this might be a little awkward, is something called offsets. So if you've ever tried to like mod a game where you had to mess with memory addresses and stuff like that, we don't like reference the variable or the value. We reference a memory address, and then so we have like a base address, and then we have an offset, and then you add the offset to it to get the location. So we could think of our camera position as the base address, and then the offset, so base, and then get the offset from here, so offset. So how do we determine that? It's fairly simple, because if the player is still in the middle, we know that player position is equal to the same distance. So it's equal to 0, 0 plus player position. So in this case, it's equal to negative 1920 by 0 plus player position. So to get the player on-screen location, I know this sounds ridiculous, like they have to explain this, but this is what I had to go through to sort of think and figure it out, is camera position plus player position equals player's on-screen position. Seems kind of weird, I know, but that's how we kind of go through that and get that figured out. So we've got our variable set up. Let's go ahead and set up the actual the function that's going to say, hey, where are you on the screen? Do this if you're in this specific spot. So we'll make it a private void, and we'll call it auto move cam, I guess. Auto move camera. It's gonna take two floats. So float, we're gonna call it float v tolerance, and float h tolerance. Oops. So the way that these work is we have a vertical tolerance that allows the player to say, hey, if you're within this range, don't move the camera. It's fine. This way, it's not like just hard stuck on the player. With that said, we want it to be customizable. That way, when we say go and make our little, level designer and we just follow camera around, it doesn't, we can press the W and it feels responsive without being stuck there. So moving back into this specific spot, it's really simple. There's two ways to do it. We're going to break it up into 4 individual if statements because we might want to do something different for each one. We're not going to in this video, but you may want to. So if adjusted player, we didn't call it adjusted player position. We called it player screen position dot x is greater than, so we take the screen size dot x to get the halfway through dot x divided by 2. So if it's greater than halfway through the screen plus h tolerance, and then we can just put some brackets opening and saying, hey, console.writeLine, right line, you are on the right side of the screen. All right. And then we'll actually copy this one. And theoretically, these could be combined, and we'll talk about that in a second. So instead of greater than, we'll do less than. Less than. And we'll say minus h tolerance. You are on the left side of the screen. So you could combine these. So if you copy the stuff inside the parentheses on the second if statement, and you go up to the first one, and at the end of it, you put an OR symbol, or an OR thing, and that is 2 bars. I don't know the actual name of the symbol here, but it represents an OR. And you hit paste. Because we actually do the same thing regardless on if you're left or right, because the speed of the player is going in the direction that we want the camera to go into. And yeah, so you could do that if you want to. I'm going to not in this case. for potential, it's a small adjustment if we have to in the future, but just for the potential that we may want to do something specific based on the side of the screen that we're on. Moving on, we're going to say if player screen position dot y is greater than screen size of y divided by 2. And since we're doing greater than, we want to do plus vtolerance. And it's pretty much the same thing. Say, so this would be the bottom. You are at the bottom of the screen. And then we can just copy and paste this and do the same thing for the top with the subtraction. And if it's less than, you are at the top of the screen. So now this will do that. If we meet this criteria, we have to actually tell it how to meet this criteria now. So let's define player screen position. There's a couple places we could put this. Since we're updating the camera, I am comfortable putting this inside of something like on draw. So we could say something like, let's see here. So this player screen position equals camera plus player dot position. I'm comfortable putting that in here since it's on draw. So when we say, oh, we're about to draw, let's update the player's on-screen location. I think that's fair. There's a few different places we could put it. Like you could put it right in window paint, but I think that's not very cool. But since we are actually in window paint right now, there is something we do need to do. So we need to actually tell it to like move the camera. Like we have an X and a Y value, but it's not doing anything with it. It's just changing it. So let's go ahead and change that. To change it, we need to say g.translate camera, or translate transform, excuse me. So it changes the origin of the coordinate system by prepending the specified translation to the transformation matrix of this graphics, which is exactly what we want. And we say camera.x and camera.y. So the beauty about this is we don't need any if statements or anything like that. If camera's not being auto moved, it's at 0, 0. That's where we want it. So in the future, let's say we don't want auto moving camera, but we want to like move it ourselves. We just move the camera and it'll automatically move it for us. So this is probably something we should have done a long time ago anyway, even if we weren't planning on using it immediately, because it's a call that we will need. And now we can use it. So we've got the camera being set up. The only thing that's happening is we are not actually telling the camera where to move. So how do we do that? We could put this in a few different places. I think on update's not a bad spot if we put it first. So it has to be handled. Should it be handled after the input? I think it's okay handling it before the input since it'll be caught next frame. So we'll put it here, but if we need to, we can move it. Say this auto move camera. And what I want to put here is, oh man, there's a couple ways to do this. I'm not a big fan of this. So what we'll do is we'll make variables for it. So we'll say vector2. We'll make it we'll make it private for now, but vector2. And we'll say camera, or we'll say auto cam tolerance. And then we'll toss in this auto move. Oh, here we'll take we'll do it that's fine. So we'll go in and say auto move cam auto move cam, oh shoot, no, I just named it and I don't even remember. Yeah, auto cam tolerance dot x, auto cam tolerance dot y. There we go. And I got that backwards. I'm gonna rearrange these because x goes first. I don't care what anyone says. So H tolerance and V tolerance, because you always do X and then Y. At least in my opinion. If you don't care, then you can order it however you'd like. It doesn't matter that much as long as they are correct, so you know when you're putting where. So we're still not telling the camera to move. So a couple things. Firstly, we haven't actually changed the variables. It's like, hey, how much do we move the camera? And we haven't actually, how much tolerance to have. That's okay. but we also haven't told it like what to do here. All this does is print. It doesn't actually move anything. Let's firstly set up our tolerances. So we can just say up when we create the object or create the AutoCam tolerance. Say equals new vector2, and this will give us default tolerances. We can say screen, what is it? Oh man, screen size dot x divided by 2, and screen size, is that going to work? I don't think that's going to work. Divided by 2, because we are up in the little like class variable area. We can't use non-static. Yeah, okay, that's okay. We'll grab this new vector2 and we'll toss this in the constructor. So this will be our default setup. We'll just toss this at the top. Okay. Say player. Whoa. Say player or not player. AutoCam tolerance equals new vector2. So this will create the AutoCam tolerance right away. And divided by 2 is a little rough. We're going to do divided by 5. So the way that this works, and I guess it'll be the last time we bring up Paint. This is what I was thinking of when I was like, is this the last time? Don't save. So instead of doing a static hard-coded number, I mean, we're kind of hard-coding something for now, but later we'll change it. When you have a screen like this, and then you have a screen like this, so let's say, you know, you have a 2K screen, and so it's like 1440 40p and 1080p. So not uncommon. I know 1080p is way more common than 1440, so we could build everything around 1080. But you got 1080 and 1440p. So how do you get? It's like, all right, I want the player to move between. I want the camera to look like this, the tolerance there, and tolerance like this. So the player's in this sort of circle. And you want a very similar circle here, like this. How do you get that? So what you can do is say, because it's like, okay, on this one, this is, if we got 1080 from here, this is about 300 pixels, and on this one, it's 400, almost 500. How do you get that? Well, you just take it and you divide it by this much. It's like, oh, okay. You take a slice of the screen and you say, okay, that's how much you want. So in this case, we'll divide by 5 because 5 is easier, but I don't feel like drawing lines here. I can't really get that even. But you get the idea. So what this will do is say, hey, you are this much in left or up. And same thing for here. So we'll work on different screen sizes if we do the math division based on the screen size. All right, so we've got screen size divided by 5. And all right, so there is a little bit of caveat we'll talk about in a second, but we should be able to hit start and at least get it telling us that we're in the bottom left. We're going to go to the middle, and we are now at the bottom only. We're going to jump up on this cube, and we are not too far for the camera. If we jump, we get the top. If we fall back down, we get to the right and the bottom. So we've got, that was not really intentional. That was, I mean, I knew kind of like if I was on the ground, it would be at the bottom. If I jumped, it was at the top. This cube's kind of in a very good spot for testing purposes. But okay, so let's actually tell the camera to move. That's the last part. Now, well, I said there's a caveat. We'll talk about that a little bit in a second. Why is this different size? Tolerance. Oh, these things have spaces. That's goofy. All right, there we go. Okay, so let's get rid of these print statements. No, this is being called, so we've got theoretically the hard part out of the way. So to change the camera location, we want it to move alongside with the player. So if we say, what would we say for something like this? We'd say this dot camera dot x plus equals this dot player dot speed dot x, because that is how much the player is moving. And then we'll do the same thing for the other one. This is where it can be like combined. If this is all we do, then these two things can be combined to one if statement. Down the road, you may want to split it if you decide to do something else, but for now, I'm going to keep them separate. We could do the same thing for y. Say this dot camera dot y plus equals this dot player dot speed dot x. Well, not dot x dot y, excuse me. And we can copy and paste that over. So let's go ahead and run this and test it out. See what happens. And it looks like we're a little high. and it's moving in the wrong direction. So like if we get to the edge, it moves us. That's great, but that's not going to work. And the reason for that is actually very simple. So when we translate the camera, and I guess I'll bring out Paint one last time. I know I said that last time. We've got our screen, and then we've got, actually it's like a big area. Let's say the screen covers this. We want to translate this by the player speed. So when the player moves to the right, so player goes to the right, and we want to, well, I guess the player's going to the left, so boop. We need to actually subtract the player's speed rather than add it. It's a little goofy. And this actually applies to all of them. Oops, I'll bring this up here. Don't save. So we just changed these over to minuses. That was something that I figured I would share, was interesting, because we're essentially moving it opposite to what ad's happening on the screen. So we see there's a little bit of something going on here. We technically meet the criteria the instant we spawn in. It looks like we were able to sort of fix our vertical height here, and we got ourselves kind of locked in the sweet spot. I'm not exactly sure how that happened. Maybe we moved too fast or something. But we can't get ourselves into the center of the screen. So why is that? So when we spawned, we are less than this. So we meet this criteria to always have it affect our speed. How can we fix this? There is a couple ways to do it. I haven't found what I think I would consider the best solution. The best solution for me is the camera says, "Oh, you're not in my tolerance zone. I want this camera to slide over to you." No, it doesn't do that. Not yet. And this would be the place to do it. However, this place also thinks it's like, hey, when you're hitting it, if we change the speed to try and catch up with the player, it's going to start jittering. For example, we're on the left side, so I'm fairly sure this is, we'll say, left side. We'll just label these two. If we say, okay, well, I think we want to subtract another 2F. So like it puts us into the center, and that's great. And when we go to the right, we're good. But if we go to the left, we start jittering, because what it's doing is the camera's catching up, and then it's uncatching up, and it's catching up and uncatching up. So it's changing speed left and right, or like really quickly. So that's not ideal, and I'm not sure if there's a good way to fix it. So for now, instead of doing that, and to be honest, this is probably going to be something that it gets addressed later. But for now, what we're going to do is tell the camera to, or when the player spawns, tell the camera to snap to the player's location and stick him in the middle of the screen. And that's actually why we have this enable variable. This way you can say, hey, for a second here, don't do that. Don't enable AutoCam. When you're ready to enable it, go ahead and enable it. So to do this, and I made it private for a reason. I want it to be accessible publicly, but not through the variable. We'll say public void enable AutoCam. We'll enable. And at the end of this, we'll say this dot enable AutoCam enable. Oops, that's not what I want. That shouldn't call itself. These variable names. Oh, did I call these the same thing? Oh my lord. Okay. We'll change we'll say toggle AutoCam. There we go. That is ridiculous. Equals enable. That's my bad. So now this is similar to other things we've done. For example, these deregister and register. The difference is these don't do anything right now, and we don't know if we will. In this case, we do want to do something. So when we say if enable, we actually want to say, hey, snap to our player's location. All right. This way it's not going to be an issue. So if we do if enable, we can get player. Well, okay. The way it works is we want to set the camera X and Y to the player's position, but offset so the player's in the center. So we say camera.x equals negative, because again, we are offset here. We are offset based on player's location to put them in the center, and we don't do the positive for it. it's a little goofy, but dot position dot x plus, and we're going to add the screen size dot x divided by 2. So that way we get halfway in the screen, and that's it. We could do like the player scale to get it exact, but it's going to fix itself in a second anyway when the player moves. And we could do the camera.y as well. So camera.y equals negative player.position.y plus screen size.y divided by 2. It's already got it set up. So now we can say, hey, the camera's just been told to AutoCam, let's go to the player's location. In the future, we can make this smooth instead of just like teleporting, but for now, it's going to teleport it. So let's go ahead and there's 2 places we could do this. So we could have the player do it. The problem with the player doing it is there's no good place for the player to do it. You'd think, all right, let's do it on the constructor. However, the constructor, when we do it at the constructor level, it doesn't count, even if like it doesn't count as a instance of an object yet because it's not been fully constructed. So the actual game window doesn't have access to things yet because it's not done. We would have to do it outside of the constructor. We'd have to say, let's see here. We'd have to make like a on start function that happens after it's been constructed or something. Because update's not good, draw's not good. Those are every frames. Handle inputs every frame. Move left, move right, jump, drop, check collision, clamp. All these things could be happening every frame pretty much. So the constructor is the only thing that happens on start, and we can't like say make a new function and say call on start. We could do like maybe a delay or something, but no. So we're not going to call it from the player this time. We're going to call it from the game window. However, later we're probably going to have to call it from like maybe the level or something. Like the level should realistically probably be the one that determines AutoCam status. Like a level could set like a camera track or something and tell the camera where to go, or have it follow the player. So it's probably good that we don't have it calling from the player when the level should be calling it. And then a default, it's like, okay, the level hasn't said what to do. Let's just use AutoCam. So when we create our player for testing here and the on load, we can just say this dot toggle AutoCam true. So player has already been constructed by the time we get to this line, and this will allow it to access the player's location. So this will fix that issue, theoretically. Yep. And now we can go along on our merry way. And we can fix tolerances. We can make them a little bit like smaller or whatever. So you can make them just smaller numbers, or we can actually use like division here. So it's like, okay, do like divided by 9, which is fairly strict if I'm not, fairly strict. Almost to the point where we're like, yeah, we got very little movement. So pretty cool. And in the future, again, we're just going to have the levels control that stuff. The levels are going to have a lot of control over everything, pretty much. So in the next video, what we're going to do is we're going to create some sort of map generator. Not generator, but a map reader. So we're going to define how a level reads into it, probably with a dictionary. So I'll probably make maybe a level reader object or a level object, and it has like a read input, and then we could do like a dictionary that defines, hey, if we see this, this is what should be put in that place, and then we can add to that dictionary. This can also be used to control, like, let's say, hey, we got an update that adds new stuff. We can keep the old dictionary and be like, okay, if you're on an old version, use this dictionary to load things, so that we have cross compatible levels that don't get updated. So cool stuff down in the line. But we'll keep it pretty basic in the next video. We'll save some complicated stuff for later. And I'll see about fixing up the camera issue, seeing if we can make it a little better. But for now, it is what it is. Anyway, thank you for watching, and I hope you have a wonderful day.